Topic 9 in Unit 7 is about multiplying polynomials with double distribution. I'm going to go ahead and get it out of the way now. This method used to be called FOIL. So you might hear myself, an older sibling, a parent refer to FOIL, and all they're talking about is exactly what we're going to do in our lesson today. We just typically don't use FOIL anymore because it doesn't apply to all situations, and I'll explain that here in a little bit. So, distribution, you should understand because you've been doing it since 6th grade, but also because you did it yesterday with polynomials, right? So we're going to do it again today. But this time we're going to have like binomials times binomials or trinomials or multiple pieces where it isn't quite as clean of a process, but it's still just as simple. So number 1 says find the product using the algebra tiles and algebraically. So for number 1, we have x minus 1 times x plus 3. Well, the algebra tiles essentially are just creating an area model. If I said, what is 4 times 5? Way back when you were first learning about it, you might say, okay, that means I would have a rectangle where I've got 4 along this top, and I've got 5 this way, and that's going to create an area of 20, right? You'd count your little boxes, and you'd say, oh, that's 20. Same process here with algebra tiles. So when we do x minus 1, we're going to have that along the top here, and we're going to draw that by drawing a bar first. That represents our x. Minus 1, you're just going to draw a little box, a tinier box, but color it in to make it negative. Okay, that's the top of our little rectangular area here. But then along the side, we need to do the other factor here, x plus 3. So I'm going to draw another bar. That's my x. Plus 3 means just 3 positives. So now I'm ready to multiply. Well, again, just like when I said, okay, 4 times 5, and I kind of drew these lines and then drew these lines, I need to do the same thing with my algebra tiles. So I'm going to draw what I sometimes have referred to as like the alleyways, okay? In between those two algebra tiles, I've got a space. So I'm going to draw a little alleyway there. In between these two algebra tiles, I've got a little bit of an alleyway, so I'm going to draw that there. Another little alleyway here. Alleyway here. And then just to finish it out, I'm going to go ahead and close off my area here by drawing an alleyway or a street after my final piece on both the top and the side. When I do that, what I've essentially created is a little grid for me to fill in with more algebra tiles. So I can see, okay, well, this is space for a big ol' x squared. I can see over here, this is space for a bar, which is an x. This is space for an x, space for an x. But now I've got little spaces here for the little boxes, okay? Now, I haven't considered the signs yet. So this is where you kind of have to do the matching game a little bit, play a little battleship. So we've got a positive x here and a positive x here, which is going to create a positive x squared. But then this positive x is also being multiplied by this negative 1 up here to create a negative x right here. Okay, so then I'm going to go to my next row here. I've got a positive x right here that I'm multiplying by a positive x, no, sorry, positive 1 with positive x, so that's going to create a positive, positive. But then again, when I match up this one little box here with this negative box up here, it's going to create negatives all the way down here. Well then, to get my official answer, I just look at the pieces I've created on the inside. Just like how when you did 4 times 5, you just counted up your boxes, we now need to count up our boxes we've created. So I've got an x squared. I've got quite a few x's here. I've got 3 positive x's on the bottom and this 1 negative x on the side. And I've got 3 little tiny boxes at the end. Well, really, thinking back to way back when, a positive and a negative here create a 0 pair. They kind of cancel each other out. You can see that both in the algebra tiles as well as over here in the expression. 3x and negative x, that's just going to create 2 positive x's. So I've got x squared plus 2x minus 3, and that will be my final answer. Now let me go ahead and just pause here and say that algebra tiles are not the end-all be-all. If this problem said 25x plus 64 times 327x minus 24 or something, we don't want to draw 327 boxes, right? So algebra tiles only get you so far, but they do help to provide a visual, especially for those of us that like to have that visual representation. But let's talk about how to do this algebraically. So our problem algebraically was x minus 1 times x plus 3. We are simply going to distribute these pieces, making sure to distribute everything from the first factor to everything in the second factor. So this x needs to be distributed to the x as well as to the 3. Well, x times x is x squared. X times 3 is 3x. Then again, I need to multiply the negative 1. Negative 1 times x and negative 1 times 3. So I've got negative x minus 3. That's why it's called double distribution, because I'm doing distribution twice, really. Once for the x and once for the negative 1. Okay, so I've got x squared plus, well again, you want to make sure you combine like terms here to simplify, 2x minus 3. Did I get the same thing as when I did it with the algebra tiles? Absolutely. Okay, so looking at number 2. They've eliminated the need to do the algebra tiles. If you like them, please continue using them, but do not feel pressured to, especially just because it's not, sorry, my email is chiming at me, especially because it is not realistic when you have really large numbers and large coefficients. So instead, we're just going to focus on this double distribution. So I'm going to start by multiplying my x to each piece in the other term. So I've got x squared minus 5x. Then I'm going to multiply the negative 3 to each piece. So I've got negative 3x plus 15. Don't forget your integer rules here. We've got a negative times a negative, which is a positive. Then I need to combine like terms. So x squared minus 8x plus 15. Simple as that. Where's 3? Oh, there's no 3. Number 4, again, same process. The reason this used to be called FOIL is because they would tell you to multiply the firsts. So this first number with this first number, 3x times x is 3x squared. The O is the outers, so 3x is on the outer edge and 4 is on the outer edge. So 3x times 4, which is 12x. The I stood for the inners, so this would be negative 2 and x, those are on the inside, so negative 2x. And then L is for the lasts. So negative 2 is the last one here, 4 is the last one here. So negative 8. Okay, so we combine like terms, 3x squared plus 10x minus 8. Now the reason FOIL doesn't work, we've stopped using it, is for instances like number 5, or really instances like number 7 where we have a trinomial. Okay, on number 5, let's think about our exponent rules. Can I just distribute the square? No, you cannot, because you have this minus sign in the middle, okay? That eliminates the ability to just easily distribute it. You have to do it the long way and think through 2 minus y times 2 minus y, not just distributing the 2. It does not work that way. And in fact, I can prove why if you just use numbers instead. You don't necessarily need to write this part down. But if I say 8 minus 3 squared, well, let's do it PEMDAS and find out what the actual answer should be. 8 minus 3 is 5. 5 squared is 25. That's what my answer is supposed to be. If I try to just distribute, I'm going to have 8 squared minus 3 squared. Well, 8 squared is 64. Minus 9 is not 25, right? So you cannot just distribute the square. You have to actually multiply it out, use that double distribution to figure out what the answer should be. So I've got 2 times 2, which is 4, 2 times negative y, which is negative 2y, again negative 2y, and positive y squared. So 4 minus 4y plus y squared. You could box that in. Mathematically, that is correct. But you typically see the variables written in descending order when you're looking at their exponents. So you typically see this written as y squared minus 4y plus 4. Either one should be fine. Okay. So number 6, again, same thing. If you feel like you've got this, feel free to pause and see if you get the same thing that I get. 2x squared minus 2xy plus 3yx minus 3y squared. Remember that these are still the same thing, even though the y and the x look like they're in a different order. Just because I wrote them that way doesn't mean that you can't just switch them around, right? Everything's being multiplied. So 2x squared plus xy minus 3y squared. Because a negative 2 and a positive 3 is positive 1. So number 7, again, this is why we stopped teaching FOIL, and really even double distribution doesn't necessarily work all the time, because if you got a trinomial, you might be doing triple distribution. The point is that you are multiplying everything times everything. So I'm going to take that 3x, and multiply it by each piece in that trinomial. So I get 6x cubed plus 12x squared minus 9x. Then I need to multiply the negative 5 times everything all the way across. Negative 10x squared minus 20x plus 15. Then I need to make sure I combine like terms. This is the only thing that has the x cubed, so it's on its own. But then I've got this negative 12x squared, or positive, sorry, and negative 10x, which makes positive 2x squared. Then I've got this negative 9x, negative 20x, and 15's on its own. Okay. Now, for a moment, just have a little check-in with yourself. Do you feel good about today, about this video and what you've learned so far? If the answer is yes, then try to hold on to that feeling. Because what's about to happen is we're going to use word problems. And for whatever reason in math, we always tend to crumble when we start seeing word problems. It causes us to lose our confidence and make us feel like we don't understand. But really, if you understood it in this form, problems 1 through 7, then you're going to be just fine, and your understanding is much better than you think it is, okay? So don't stress when we do 8, 9, and 10. So number 8, a square tabletop. I'm going to go ahead and just draw a square. If I see a shape, I might as well write it down. Has side lengths of 4x minus 6. Well, if it's a square, that means they all are 4x minus 6, right? Might as well go ahead and label each side. I might need that. Write a polynomial that represents the area of the tabletop. Well, to find the area of a square, or even a rectangle, since this is a type of rectangle, is to multiply my length and my width. They just so happen to be the same, right? So I need to multiply 4x minus 6 times 4x minus 6. Now that I've written it like this, you're probably thinking, oh yeah, I got it. No big deal. Okay? This is just a testament to why you should draw pictures and try not to overthink a word problem. Okay? So we're going to double distribute here. So I've got 16x squared minus 24x. Also double distribute there. Another minus 24x plus 36. So 16x squared minus 48x plus 36. Okay, and I guess you could say units squared because it's area. Okay, number 9, the diagram shows the dimensions of a sandbox and the wood frame that surrounds it. Write a polynomial that represents the area of the wooden frame, the shaded part, in simplest form. Well, again, don't stress over this too much. Think about it in terms of just normal numbers. If this had just said 10 and 6 and 3 and 4, you would not be stressing. You would figure this problem out no problem. You're going to use that same process, just so happens you got some letters involved, some variables. So I need to find the big area and subtract the small area. That's going to be my overall plan to get just this shaded region in between. Okay, well, to find the big area, I need to do length times width. So 3x plus 5 times 3x minus 4. And to find the small area, I'm going to do x times x plus 1. Length times width again, but just with the inner dimensions. So now I do my double distribution. So I get 9x squared minus 12x plus 15x minus 20. Combine like terms. Okay, so there's my big area. Now I'm going to put it in parentheses just to make sure that it is set apart as the big area. Okay, in fact, I might even just do red ones just to represent the fact that that's the big area, because I'm about to subtract the small area. Okay, so small area, I don't have to do any double distribution, but I'm still distributing x squared plus x, and just move it down here. Now it's important that you notice I put those red parentheses, because when I go to subtract, I need to make sure that I subtract this whole thing, which means that negative gets distributed. Okay, so I'm going to go ahead and just rewrite the whole first part. but when I go to subtract that whole right-hand side, the whole small area, I need to subtract x squared and subtract the x. Okay, so now I'm able to combine like terms one final time, and I get 8x squared plus 2x minus 20 units squared. Okay, or I guess it's centimeters, sorry. But that's a piece a lot of people forget, is to distribute this negative right here, because it's a subtraction symbol, but remember, it's kind of a negative at the same time. All right, number 10, last problem. Find the measure of the volume of the prism in terms of x. Answer in simplest terms. Well, think back again. Volume is length times width times height when you have a rectangular prism, or area of the base times the height, which still is going to be length and width times the height. So let's start with just that length and width piece, that area of the base piece. I'm going to do x times 2x squared minus 3. That's going to give me the area of the base. So I distribute, I get 2x cubed minus 3x. That's my big B. And then I need to multiply that still times my height. Well, my height is x plus 3. So now I see where I'm faced with that double distribution again. So I've got 2x to the 4th plus 6x cubed minus 3x squared minus 9x. I believe that is correct. Okay, feet cubed, because it's volume. Alrighty, so now you have some practice. Again, don't let the word problems shake your confidence. You know how to do the skills. Word problems are just a matter of trying to figure out how to apply the skills you've learned. Most likely, your word problems are going to ask you to multiply some polynomials together. It's just a matter of making sure you're multiplying the right ones. Okay? Make sure you ask your teacher if you have any questions or need any help with anything. I'm sure they'd be happy to help.